Hello and welcome. In previous video, we have seen the whole heapification and build heap process, correct? I have explained you with the help of a tree how to build heap and heapify it. Okay, so now in this video, we will see the code for it, the Java implementation of build heap and max heapify. Fine. We will see the code for max heap and doing some minor modifications. What you can do, you can also write a code for min heap, and you should do it. You will clearly understand how to write a code in Java for max heap and min heap if you implement min heap by your own. Okay, so now let me start with the code. So we will use scanner, take the input scanner sc equals to new scanner system.in, fine, system.in. Okay, next what we will do is we will simply take a variable n that will give me the max size of my heap, the size of my heap. Fine. After that, what we have to do is we have to create another class for heap. Okay, so this class will create different objects of heap. Fine. So from the main class, what I will do, I will call this class max heap, and in this class I will create my heap and I will write the functions, the methods. There are different methods of my heap class. Okay, that is build heap, max heapify, and there are some other methods that we will see after this. So what we will do is we will create a private int an array known as heap. We will create a array known as heap. Done. Then we will create a variable for its size, private int size, a variable for the size of heap. Next we will create a variable for a max size of heap. Now what is difference between size and max size is, I can create a heap of size 20, but I want to store only 10 elements in it, so size becomes 10 and the max size becomes 20. Okay, after that I will create one constructor and I will pass the max size to it. So whenever I'm creating my object of my max heap class in main, this constructor will be called, and in that I will just pass the max size of my heap, whatever I want. The max size of my heap, whatever I want, I will pass it. Okay, the semicolon won't come. Now what I will do, I will simply write this dot max size equals to max size. I will initialize size to 0. And I will initialize heap equals to new int, that is the initialization, and here I will simply write this dot max heap, this dot max size plus 1. Now why plus 1 we are doing is we will always start with 1. I have already explained that we will always start the index with 1. So at index 0, what we will do is I will put a maximum value, my integer maximum value, integer dot max value. We will never use it. Okay, we will never use it, this value, only we are storing the integer dot max value in it. Okay, so what we have done is we have created a constructor here. In this constructor, max size will be initialized with max size will become 0. Okay, whenever we insert an element into our heap, at that time I will increase the size of the heap. Okay, then heap equals to new, this is initialization of my heap array, fine, with this dot max size plus 1. Now what I will do, I will come to my main class again, and in this main class I will create an object of heap. So max heap, this is a reference variable, max heap equals to new max heap. This is an object creation and I will pass n to it. That is my max size, I want it to be n. And for this example we will take max size and the size same. Okay, so now what I have to do, I want to insert. So before this for loop, I have to go back to my max heap class, and here what I want to do is I want to simply insert. So I will in the beginning what we will do is we will simply create a normal insert class. We will simply create a normal insert method, not a class, sorry, normal insert method. Fine. Afterwards I will show you some modifications in this method. So int n, and now what we have to do is we have to simply create a class. So plus size equals to simply n. So this is done. So what we are doing is we are passing an n into it, we are passing an element. So what you can write is, if you are confused between n, so just write an element here. So we are passing an element from our main method to this one. So whatever you want to insert, you can insert it here. Fine. So if you want to insert 5, just pass from here 5 and it will be inserted into a heap, and the size will be increased, If you are adding 10 elements, then the size will become 10. If you are adding 20 elements, then the size will become 20. But what we have to keep in mind that the element should be less than n. The element should be always less than n, because the max size of heap is less than n. Therefore, the loop which I will create will go maximum to n, and it will not cross n. It will not cross the max size. It will only go till the max size. Okay, so that my size does not exceed my max size. So int I equals to 1, simply I less than equal to n and I plus plus. Okay, now what I will do, I will call simply from max heap my reference variable, the insert method, and this insert method I will pass whatever the user is inputting, that is sc.nextInt will take whatever the user is inputting, and from that it will pass here, and simply it will be inserted in my heap. So this was simple. Till now we have done nothing different. Okay, till now it is very simple. Now what we have to do, we have to write the methods for build heap and max heap and all other methods that are required by those two methods. Let's create a build heap method. So void build heap, and here what we have to simply do is we will create a variable j. This is a loop variable, and I have told you the build heap function starts from the first non-leaf, that 1 to n by 2 is my non-leaf, and from n by 2 plus 1 to the max size, that is the size of the heap, is my leaf. I have explained you this in the last video, so I will here calculate my n by 2 value. Fine. So math.flow, and here simply pass size, that is my size of the heap, and divided by 2.0. Okay, so because this is double, I have to do the conversions. So for int j, so I will begin with j, that is nothing but, what is this? Just think about it. What is j? What j represents? J represents the first non-leaf. J represents the first non-leaf. If I go back to our explanation, so this is my first non-leaf, so build heap function starts from this. Okay, build heap function starts from this, but this was already max heapified, so we went to 3, and then we converted 3 and we swapped with 13. Okay, so we need a swap function also. This is just for a revision, so we need a swap function for this. Okay, we will start with our first non-leaf. So how do we calculate our first non-leaf? So this was to calculate our first non-leaf. Then what I will do, till I greater than equal to 1 and I plus plus, sorry, I minus minus, because we are decrementing, Now I will call a function known as max heapify. I will call a function known as max heapify on the node which I is pointing to, and I will pass my heap and I. Fine. Now here what we will do is we will create a max heapify function. So private void max heapify, and here I will have my int heap comma int I. Fine. Now what we will do here is, it's very simple. It's really very simple. So we have some steps in max heapify. I hope you remember the steps. First of all is, if my node is a leaf, then we have to do nothing, just return. Second of all is, just check for its left child and right child. In this case, right child was not present, so check just for the left child, and whoever is greater, if the leaf is greater, then if the child is greater, then swap it. If it is not greater, then we have to do nothing. Okay, and there was the largest variable also, if you remember. So this was just in the previous video. So what we have to do is we have to take care of all those things. Fine. So first we have to check whether the node is a leaf or not. Fine. Why we have to check is, we are starting from non-leaf, so you will be confused why we will checking for leaf. But because we have to check, because when this is swapped, that is 13 and 3 are swapped, so now 3 became a leaf. It was not a leaf before, it became a leaf now. So when max heapify is called on this one, that is on 3, now it will say that I am a leaf, you do not have to do anything on me. So we have to check for a function known as isLeaf, because it is a recursive function. So we will create another function isLeaf to check whether what I am pointing to right now is a leaf or not. Okay, if it is a leaf, we will simply return. This is a base condition. This is a base condition for recursion. So what we have to do now, we have to create a function known as isLeaf. We have to create a function known as isLeaf. What isLeaf will return, it will simply return true or false. It will simply return true or false. So private boolean, because it is returning true or false, therefore boolean isLeaf and int position of the leaf. Fine. Now if my position is greater than, what is the size? Size divided by 2. Why? Because the leaf starts from size by 2 plus 1 to the maximum size, so we are checking that. Fine. So it is greater, therefore I am not writing plus 1. If I am writing greater than equal to, then you have to write plus 1 also. So simple pause should be less than equal to position should be less than equal to the size. So what it is checking, my leaf will begin from size by 2 plus 1 and it will go to the size. If it is between this range, if it is not in this range, then it is not a leaf. So simply return true. Okay, and else return me a false. Fine. So this function is checking whether the position I am at pointing at right now is a leaf or not. Fine. So the next thing we are doing is, it's very simple. So what we have to do next, we have to calculate the left child and the right child. If you remember, we have to calculate the left child and the right child because we have to compare them, because we need to compare them. Okay, so let's calculate the left child and the right child. So int left child is my variable name equal to 2 into I. Correct. So 2i was the formula. If you remember, 2i was the formula. Okay, let me just do it this way. Now int right child equal to 2 into I plus 1, 2 into I plus 1, 2 into I plus a 1. Okay, just use parenthesis in case, I guess now it's fine. Now what we have to do, we have to check whether the right child is present or not, and we have to check if the right child is present, then check for the left child also and check for the right side also. Fine. So I am writing now the base conditions. So again, if right child is less than equal to the size, correct? If the right child is less than equal to size, for example, in this tree, when we are checking for the right child of 8, it will be greater than the size. It will be greater than the size, because the size is currently 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But the right child will come 2 into 5 plus 1, that is 11. So it is greater than the size. So there is no right child for this. If the right child is less than equal to size, then what we have to do is, now if heap of I, that is the node I am pointing to, is greater than equal to heap of the left child, and heap of I is greater than or equal to the heap pointing by the right child, then what we have to do, then we have to simply return. We do not have to swap it. So this was the first case here. Okay, now here 8 is greater than 6. Okay, and it does not have a right child with it, so we do not have to swap it. Fine. Now after swapping, if you see it here, 15 is greater than the left child also, and 15 is greater than the right child also, and 10 is now a leaf. So now my recursion function will stop and it will return, because 15 is greater than 10, 15 is greater than 9. So this is the case I am talking about. The I which I am pointing to, that is 15, is greater than the left child and it is also greater than the right child, then I am returning. Now this is what else I am talking about when right child is not present. When right child is not present, just check with your left child. If leaf of I is greater than or equal to heap of left child, okay, and in this case just simply return. Now this was when I was talking about 8. So there is no right child of it, therefore we went to else part or in our code, and in the left child what you can see is the 8 is greater than 6, so you do not have to swap or you do not have to perform heapify on this node, then simply return to the build heap, and build heap will start pointing now to 3. Correct. So this was the case when we were dealing with the node 8. Okay, so this thing was for node 8, the nodes which are type of 8. Okay, now what we will do is, after this, now we will move forward and we will perform our heapification. So int largest is the first step for this. So as you remember, largest is the greedy one. Whichever is the largest, it will start pointing to that index. So whichever is the largest, if the left child is large, then it will start pointing to the left child. If the right child is large, then it will start pointing to the right child. Now we have to check for these conditions. Okay, now we have checked that our right child is present, and it is now what we have checked before this, that our right child is present or not. Fine. Now if it is present, then our heap is not actually greater that, and if it is present, now what we are seeing here is that our I, that is the node I am just pointing to, it is not greater than the left child and it is not greater than the right child. These both conditions or one of them is false, therefore I am coming here. Fine. So since it is not greater than the left child or it is not greater than the right child, means one of them is greater, so this is the case I am talking about, the 3. Okay, either this left child is greater or the right child is greater. Okay, if I am coming to my largest, that means that either 2 is greater or either 13 is greater. Okay, now we have to see which one is greater, we have to check. So just simply compare this 3 with 2 and compare this 3 with 13, whoever is greater, just put the largest to that value. Fine. So what we will do, if my left child is less than equal to size, you need to check it every time. Okay. And if the heap, this is the array left child, I am accessing 3 now, is greater than heap I. Okay, I am accessing this, here is 3 heap of I and here is 2. So is 2 greater than 3 or not, that I am checking here. If in some case the left child is greater, so the largest will become now the left child. So the largest will now become the left child. Okay. Else what we have seen this. Else what we will do, the largest will become I. Largest will simply become I. Fine. Now after that, what we have to check, we have to check the same thing for the right side. For the right side also. So if right child is less than equal to size, and heap of right child is greater than heap of the largest, Okay. Now what we will do, we will simply put largest equals to my right child. We will simply put the largest equal to my right child. Okay. So now what happens is, in this 4 to 5 lines, what we have done, we have started pointing largest to the largest value among the 3. Okay, either to the parent, either to the left child, or either to the right child. Okay, we have start pointing the largest to these ones. Now what we have to do, if the largest is left child or if the largest is right child, in this case, if the largest is left child or right child, in this case we have to swap it with the parent. Okay, so if largest is not equal to I, means the largest is not the parent. I was pointing to the parent, correct? So if the largest is not equal to parent, means it is equal to either to the left child or it is equal to either to the right child. So in this case, we have seen that the largest will point to 13 and I is pointing to 3. So we have to swap this. So write a swap function, swap, and simply pass the largest and I. So it will swap. It will simply swap. So now what we have to do, we have to implement a function named as swap. So we all know how to implement a function named as swap because we have done it so many times. Fine. So just simply implement a swap using our temporary variables. You can simply implement a function named swap. Fine. So what you have to do, just declare a temporary variable in temp, and here temp equals to heap of largest. Okay, and then heap of largest equals to heap of I. After that, at the last, heap of I will be equal to temp. Okay, so this is done. So this was the swap function. So we have swapped largest and I. Afterward, what we have did is, we are in this step, we have swapped largest and I. Okay, so largest was pointing to here, now we have swapped it. After that, what we have to do, we have to call the max heapify function again on the node which is just swapped. On the node 3, we have to call the max heapify function again. Okay, you all know this. So we have to call the max heapify on this. Now what it will see is, when we are doing a recursive function for this, it will see that this is a leaf. So this will return me a true and we will return. Therefore this condition was present in the beginning. So this is the base condition to stop recursion. Okay, so we'll call max heapify again. And we will pass our heap and we will pass the largest. Fine. So I have told you everything about this. We have seen in the last example which I have explained why we pass the largest. Okay, how do we swap, how do we check. So this is what this is doing. It is using the largest variable to keep track which is the largest value. Okay, and if the largest value is between the left child or the right child, we will swap it with the parent. So we are swapping here with the parent. Okay, here we are checking whether the right child exists or not, and if it exists, if the heap of the parent is greater than the left child and it is greater than the right child, then we will simply return. We do not need to swap anything because the parent is greater. So for example, here 17 is greater than 13 and 8, so you do not need to swap. You just check. If it is greater, then just simply return. There is no need for max heapification. Fine. So there is no need for recursion also. It will simply return in the second step only. So therefore that function was there. Okay, so this was max heapify and the build heap. Now what we can do is, we can simply use the main function. Okay, and here max heap dot build heap, and I will call the build heap function here. is done. When I call the build heap function, it will automatically call the max heapify function already. Okay, build heap will inside call the max heapify function. After this, what we have to do is, let me insert some elements. Okay, and before inserting these elements, let's also create a simple method for printing the heap. Okay, let's create a simple method for printing the heap, because we haven't created a method for printing it till now. Okay, so we have to create a method for printing it also. So let's do here, that is a void print heap. Okay, print heap and void print heap. And here, so for simple for loop, for int I equal to 0 to I less than size and I plus plus. Okay, sorry, we will start from 1. Okay, so size equal to size and I plus plus. Now here simply s out system.out.println heap of I, that is the array with the index I, plus and a space. Okay, so this is done. So do not use println if you want to in a single line. So before heapification, let's check. Before calling build heap, before build heap, what is my array looks like, what is my heap looks like. So max heap dot print heap. Okay, now I will call the build heap function. Now let's see after build heap what will happen. So I will just use a different line, and let's see after build heap what will happen. Okay, so after build heap, after build heap, so let's see what will happen after build heap. Just call this function again, that is max heap dot print heap. Okay, now before heapification, let's see what will happen, and after heapification, let's see what will happen, how are the changes. Fine, so I will use the same example here also. I'll use the same example here also. So how many nodes I have? 1 2 3 4 5 6 7 8 9 and 10. I have 10 nodes. Fine, so I will input this 10 nodes. So the size, max size is 10, and I will keep the size also as 10. So first node was 1, then 17, then I think 10, then 3, after that 8, and after that we have a 15, I think, then after that we have a 9. Okay, then 2, 13, and I'm doing the original one, and 6. Fine, so this was my heap. So before build heap, this was the answer, correct, whatever I inserted. So after build heap, what will happen? It will perform the heapification process, and this will be my answer. So let's see. So this is the heapification process. We have seen the first is 17, then 13, then 15. So 17, 13, 15, 3, 8, 10, 9, 3, 8, 10, 9, 216, 216. So this is correct. So this, our code is correct. Now let me show you how this code is running. Let me show you how this code is running. So I will show you with this debugger and the for loop. Okay, for the same input, what is the sequence of our execution, of the code execution, what is the sequence? Okay, just give me a minute, and here I will paste it. Now let's see what will happen. So insert function is called. Now insert function will go to the insert function of my class, that is the max heap class, and it will increment the size also. See, the size is 0, it will increment it, the size became 1, and it will add 1 to my heap at the variable 1. Okay, next what we'll do, we will again insert. So this time we are inserting a value of, I think, 17. The element is 17, correct, size is still 1. After insertion, size becomes 2, and on the index 2 the 17 is inserted. Okay, this is how the elements are inserting. So after that, my element is 10, so the heap size becomes 3 after insertion, and on the 3 we have a 10. So after this we will go with 3, element is 3, the size is 3, the size becomes 4, element 3 is inserted on the index 4. So this is how my elements are inserting. Okay, this is how the elements are inserting. So I think we have till 7, so just skip this one, and at the end what we will do is, the last element is inserted, that is 6, and the size become 10. So we have 10 elements inserted in our heap. After that, we are calling a function for writing system.out.println. It will write before build heap. It will write before build heap. So you can see here. After that, a print heap function is called. So it will go to the print heap of my max heap class, and it will simply print my heap. It will simply print my heap. So it is a for loop, 10 times and 10 times, and it will simply print my heap. As you can see here, it is printing those values. Okay, so it prints my heap. After that, it will go back and it will see a build heap function is called. It will see a build heap function is called. So now in this build heap function, it will go to the build heap function of my this class, and it will calculate j. So what will be the value of j? J value will be 5. We have seen this. Okay, because here 8 was starting from 5. That is the first known leaf. So I value will be initialized with 5, and we will call max heapify with I value 5, size 10, and this as my heap. Okay, after max heapification is called, it will go to the max heapify function. It will check whether it is a leaf or not. Okay, so it will check, it will return false because it is not a leaf, so it returns a false. Now it will calculate the left child and it will calculate the right child. So calculate the left child, it becomes 10. Calculate the right child, it becomes 11. As you can see now, the right child is index out of bound exception. Okay, so it is not right child is greater than my size. So this becomes false, this condition becomes false because the right child is greater than the size. So this condition becomes false and we go to else. Now we check whether my parent is greater than my left child or not, because the right child is not present. Okay, yes, it is greater. 8 is greater than 6 in the beginning. As you can see, heap I is nothing but 8 and heap of left child is nothing but 6. So 8 is greater than 6. So therefore it will simply return me and no swapping will be done. After that, the I will be decreased from 5 to 4. So you have seen the I is 4. Okay, so start pointing to the I equal to 4, that is 13. Okay, so now it will go for 13. It will call max heapify for I equal to 4. So we will check whether 13 is a leaf or not. Okay, so we are here, we are currently in this phase, correct? Now the value I will decrement to 4 and it will call max heapify with the value of 4. It will call max heapify with the value of 4, and on 4 we have a 3. On 4 we have a 3, correct? So now we will go here, I value becomes 4, so 3 is not a leaf, so it will return me a false. And after that, it will calculate the left child and the right child. So the left child will simply become the 2 and the right child will become 13. So as you can see, the left child of 3 is 2 and the right child of 3 is 13. So the left child is 2 and the right child is 13. Okay, now it will check whether the right child is less than equal to size. Yes, it is less. Now it will check whether the parent is greater than both left and right child. No, so it will not return and it will come out of the if. So now what will happen, it will check for the largest one. Okay, so if the left child is greater or not, so 2 is greater, no, so the largest will start pointing to I only because 3 is the greatest till now. Now it will check for the right child. So is 13 greater than 3? Yes, so the largest will start pointing to now 13, the index of 13. So as you can see now, the largest will start pointing to the index of 13, that is nothing but 9. Okay, so is largest equal to I? No, so we have to swap 13 and 3, we have to swap. So the swap function will be called and the 13 and 3 will be swapped. As you can see inside my heap now, that first on 4 3 was there and on 9 13 was there, but now they are swapped. Okay, after swapping, it will call max heapify again on the largest. So who is the largest? 9. Who is the largest? Index 9. Who is on index 9 now? 3. Is it a leaf? Yes. Since it is a leaf, now it will simply return me a true and I will come out of my recursion and I will again go to the build heap function. Now from 4 it will convert into a 3, and this is how the process is repeated. This is how the same process is repeated again and again. Okay, so for this I was just explaining you how the flow of the program works. At the end you will get the result. That this is the result: 17, 13, 15, 3, 8, 10, 9, 2, 1 and 6. So as you can see, I have shown you what will be the result be. Okay, so at the end this will be the result. As you can see here, 17, 13, 15, 3, 8, 10, 9, 1, 6. Correct? So this was max heapify build heap function in Java. After this we will learn some more functions of heap, and after that we will do heap sort. Fine. So before going to the next video, let me also explain you the time complexities of build heap and max heapify function. So as you can see, the max heapification, if we perform the max heapification on our root, it may come down to the leaf. Okay, so it is nothing but the height of the tree. And what it is? Height of the tree, as I have explained you, is always in a max heap is order of log n. Okay, the max heapification actually depends on the height of the node. If I am here, so the height of the node is nothing but 1, so it is order of 1. If I am here, the height of it is nothing but 2, order of 2. So in the worst case, it may go to order of log n, that is the height of my complete tree. Okay, and the build heap is order of n. We have a loop that is running for n by 2 times. Build heap is nothing but order of n. Okay, and don't get confused by the build heap loop, and again in the loop we are calling max heapification. So you may think for n by 2 times we are calling a log n function, so the complexity becomes n log n. Okay, so this is not the case. Why this is not the case is because the complexity of max heapify actually depends on the height of the node we are calling. Okay, and build heap calls the max heapification function. So first build heap calls here on the height of 1, then build heap calls on the height of 2, then on the height of 3, and so on. It is the work of build heap. So when we add these heights, actually we only get order of n. Okay, So you can see that when we had these heights, the order of heights, we get order of n only. For build heap we do not get n log n. Okay, for heap sort we get n log n. There I will explain how you get n log n for heap sort. For the build heap, the complexity is order of n, but for the max heapify, the complexity in the worst case is order of log n. So you can just make notes of these two complexities. Okay, in the heap sort I will explain the heap sort has a complexity of n log n, and how it has a complexity of n log n, there we will see.